Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Adami Ismail. My metric number is AD170144. My supervisor name is Mr. Nur Hakim bin Rafai, and my panel's name are Technologist Dr. Suhaimi bin Hassan and Technologist Dr. Rizal Haq bin Abdul Haq. So I would like to present my final year project PSM2. My title is the simulation and analysis of different mold design in producing polyamide product by using Taguchi method. So for the content of my presentation, I will cover about the objective, methodology, simulation result, Taguchi results, conclusion, and recommendation. So in my final year project, there are three objectives to be achieved. First one is to create three more designs that have the criteria of injection location, runner system, and gating system to make a polyamide product. The second objective is to determine the optimum input parameters, which are melt temperature, mold temperature, and injection pressure by using Taguchi method for three mold design. And the last one is to compare the result of output parameters, which are cooling quality, sigma, and warpage, using optimum input parameter in different modes to determine the most efficient design. So for the methodology, the first one is to design the product design, which is it is a gear. So it has been drawn in the SolidWorks. So the next one is the mold design. So there are three mold design that have been designed in Morphle Advisor. So for the first design, we have the one injection location with runner and sprue. Same goes to design 2. We have the sprue and runner, and the runner we have two, and two injection location and two gates. And for design 3, we have the sprue, we have the runner, we have the gates, 4 gates, and 4 injection location. So okay, for the next is the results. So results are divided into two. Which is the first one is the simulation analysis, and the second one is the Taguchi method approach. So for the simulation analysis, the output parameter for all of three design from the Morphle Advisor simulation software can be classified into three main classes, which is the first one is the cooling quality, the second one is the sigma, and the third one is the warpage. So next is Taguchi method approach. There are total of 27 simulations were completed, including 9 simulations for each of 3 mold design. The first one is the maximum cooling time variance under cooling quality result. The second one is average sigma depth in sigma result. And the third one is the nominal maximum deflation under warpage result. So the three output parameter of this were all evaluated in this study in the Minitab. After each simulation was run in Morphle Advisor, the following findings were obtained. In the orthogonal array, each result represented one simulation. Main effect, ANOVA, and signal to noise ratio were analyzed in this study. Alright, so for the simulation analysis, the first one is the cooling quality. So this one is for the design 1, 2, and 3. uh, I have got the same result for the 3 design. So based on the table, as we can see the maximum temperature variance, the highest one is the 8.2 degrees Celsius. For the minimum temperature variance, it is all the same, negative 6.8 degrees Celsius. For the maximum cooling time variance, the highest one is the 99.25 second. So the next is the minimum cooling time variance is negative. The highest one is the negative negative 42.69. So this is the simulation, example of simulation. So this one is for design 1, for simulation 1. So the green area is indicated height cooling area of 39.1% from the overall of the gear. The yellow area indicate the medium cooling quality of 24.9%, and the red one indicate of 36.0%. It is a poor cooling quality. Okay, so this one is the simulation analysis of SIGMARK. So there are 9 array, which is for design 1, the highest of maximum sync depth is 0.13. For every SIGMARK depth, the highest one is 0.05, 0.06. Then for percentage of model prone to SIGMARK, the highest one is 2.59. So next is for design 2. The highest maximum sync depth is 0.27. The average SIGMARK depth, the highest one is 0.18. For percentage of model prone to SIGMARK, the highest one is 2.08%. Next is the SIGMARK for design 3. So for the maximum sync depth, the highest one is 0.13 millimeter. So next is the average SIGMARK depth. The highest one is 0.06. Next one is the percentage of model prone to SIGMARK in percentage. We have got the 2.59 percent. So this one is the simulation in the Morphet Advisor. So in this example, the green region, which had a medium level of SIGMARK estimation 0.0497 mm over 1 mm, for simulation 1 had covered the thick area of the gear. Next is the blue indicated represent 0% of the SIGMARK covered nearly the whole gear. Okay, the third one to be analysis is the warpage. So based on the table in this analysis for design 1, design 2 and design 3, the nominal maximum deflection is all the same, which is the value is 2.58 millimeter. And also for percentage exceeding and percentage with nominal maximum deflation, it's all the same. So in this example of the simulation, so the grid area, which had a medium concentration of deflection effect, had covered most of the gear overall with region 0.4195 millimeter over 1 millimeter of the region for simulation 1. So the red indicated area, which has a high concentration of deflection effect. So on the right of the figure, this one is the warpage indicator. Refer to the nominal maximum deflection. It is zero warpage has been in this analysis. Alright, so the second section of the result is about the Taguchi method. So based on the table, we insert the value of input parameter in the Minitab software. So the simulation findings for maximum cooling time variance, average SIGMARK depth, and nominal maximum deflection of polyamide. So this three we insert into the Minitab. So following that, main effect ANOVA signal to noise ratio analyzed were used to examine the result. Okay, the next one is the main effect. Main effect we have produced the response table for mean. The average value was derived by combining the maximum cooling time variance, average CMAR depth, and nominal maximum deflection value at each level, level 1, 2, and 3. The average output value for each factor, melt temperature, injection pressure was determined. So this one is the example of melt defect for means. Next one, the analysis of variance. The largest contribution of parameter is melt temperature, as we can see is 49.81 for design 1. This one is example. So based on the signal to ratio SN ratio, we can determine the optimum input parameter, which is for the 3 design. For mole temperature is 90 degrees Celsius. For melt temperature is 267.5 degrees Celsius, and for the injection pressure is 300. Alright, so for the conclusion, the mole design has been created in Morpho Advisors for some criteria such as size of mole, thickness of mole, running system, and number of cavity, getting system, and injection system. So after running the simulation analysis in Morpho Advisor, input parameter for each design are analyzed in Minitab software to perform Taguchi method. So for the all of the design, I have got the mole temperature is at level 2, 90 degrees Celsius, melt temperature at level 2, 267.5 degrees Celsius, and injection pressure at level 3, 500 meter pascal. The best design among the 3 mole design is design 1. Simulation show that optimum input parameter is for cooling quality, the maximum temperature is 7.6 degrees C. For CMAR is average CMAR depth is 0.04 mm, and for the warpage the nominal maximum deflection is 2.58 mm. Alright, so for the recommendation for in terms of design, it is recommended to add cooling channel in the mold design. Other than that, we need to add the venting system. So this is the recommendation to make the mold design more have more criteria. So the next one is recommended to add more inputs parameters such as injection time and machine clear open time. This is because the more input parameters to be analyzed, the more accurate and reasonable result to be obtained. In Taguchi method approach, the more the inputs parameter to analyze will produce more input parameters. That's all from me. Thank you.